Hello everyone, this is Bradley. Today this is a tutorial for this knitting on text animation. This is also the third part of this knitting tutorial series, but it's okay if you haven't watched the last two tutorials because we are going to start from scratch. It's just that I'm going to speed up the process of explanation so that I don't need to repeat for things I've mentioned for at least once. So let's start. Hello everyone, this is Bradley. Today this is a tutorial for this knitting on text animation. This is also the third part of this knitting tutorial series, but it's okay if you haven't watched the last two tutorials because we are going to start from scratch. It's just that I'm going to speed up the process of explanation so that I don't need to repeat for things I've mentioned for at least once. So let's start. So here we're in Blender. As always, we are going to use the preset which you can download for free from the link in the description. I've already imported this knitting unit I've made in the past. So let's take a plane and add a geometry nodes to create a mesh for instancing. So we string to curve. And it will be recommended to type a single simple character because the actual operation will be really heavy to operate. So you do not want to lag your machine while trying a setup. So take a realized instance because we're going to modify the mesh and then take a curve to make it into a mesh. It does not really matter with the triangle and n-gon because we're going to use the remesh modifier to give a better topology anyway. So it looks like something like this with all these kind of n-gon triangles. But if you remesh it and type the voxel size with 0.01, then you get all these kind of quads. There are some ugly edges, but it'll be fine. If you want to give it thickness, then you just need to make a solidify. But you also realize the solidify result will be very ugly, so it will be better if you solidify before the remesh modifier. Then you get a much cleaner result. Okay. So generally you can have two types of setup. Either you have the solidify or without the solidify. Okay, so this is the idea. Next, we just need to create a setup for instancing. Make sure you're selecting this mesh object so that you can go to the curve and add an empty hair, which shows up as a child, so we clear the parents. And within this curve, it has a surface deform node tree. It's for sculpting, so you can ignore that. But we're going to import this plane, so let's name it as a text object. Okay, so we have a text object and we can hide that, so that we can show that within the node tree. So we are going to face points to instance it. And let's take a point instance. We're going to instance our knitting unit. So let's take a knitting unit to the instance and we use a scale, we use the rotation. We are going to multiply with a value to offset the scale because the scale essentially is normalized to 1. So we need to increase some value if it's not, if the original scale is not at 1. So once we have that, we can weigh in the edges. Instead of using -1, we can use the X or XYZ, whatever, does not really matter. So now we have this kind of setup and you can see there are some intersection, or maybe we can use the -1. Maybe, I think it does not really matter. Yeah, so choose whatever you want or whatever you like. Then we have this kind of interlacing patterns. Next is just to do the animation. We can do the proximity fold as we've done in the last two tutorials. But instead of using proximity fold, today I want to use the noise fold. First, for better visualization of this tutorial, let's firstly go to our original text object and disable this is solidify, so everything is on a plane. And let's change some parameters, maybe decrease the scale a little bit and change it to X weighing edges. There are lots of detailed settings you can just deal with in your free time, but I think I'm satisfied with it now. And let's try to deal with the setup. So I don't have a preset for noise fold because the concept is extremely easy. So you have this noise texture and we can visualize this geometry and this noise texture. Okay, so now it looks kind of gray and whitish, whatever stuff. We can normalize it to make it whiter and darker. So we take a normalized field, and it requires a geometry. So now if I visualize this geometry and the field, so we have a white 1, white is 1 and the black is 0. And if we take a math function, then we are making a transition from darkness to completely whiteness. And this is another kind of fourth we can deal with. So we remap 0 to 1, remap 0 to 1. And we know that this scale is 0.3, so it is 3. So we take a maximum as 3. And we also need to rotate that. I've shown you last time that we are rotating Euler. Euler means rotation, and we combine X, Y, Z. Combine Euler rotation, so that we can use a degree, and we remap 0 to 1 as well. But this is the 90 degree and the reverse. So now we plug the rotation to rotate by. So now if we try to animate these values, you can see there's no instance unit. We can hide this instance unit. And then by adding these values, they're showing up with their scale, and they are also actually rotating themselves. Because when they are showing up, they're actually facing the sky and then they are rotating. You can see this result. Okay, so this is the animation. So now we can turn on the render to visualize it, and you see it is not showing render because we need a realized instance to make it showing up, and we can see there's lots of jaggedness of all these kind of curves, which we need some additional subdivision. Also, we need to resample this curve. Resample. Maybe 15 should give it kind of a smooth result, and then you can manipulate all this kind of data better. As you see, this kind of interlacing pattern. So this is the trick of eevee pattern. But you also realize there are lots of holes inside. In the actual cloth, you do not see all these kind of holes. One reason is because in the actual life, it's more and more instances, so we may add a subdivide mesh to make it more dense, okay, so that you do not see all these kind of holes when you're looking far away. But another reason or another detail that we can potentially add into this setup is that we can make it into a kind of rope structure. So now we only have this single strand, okay, but we can make it into a rope kind of structure by adding a helical connections. So by turning this radius to 0 and just giving it a little bit values, then you realize we are turning one curve into 3 curves. Okay. So we can take a value precision to precisely manipulate this radius, something like this, and we can use a float range to control the rotation of it. So you can see that let's turn this step size maybe into 2. And we can also give the entire setup some thickness by turning a set radius. And let's look at the strip. So now we can take another value precision to control this thickness. Take a 5. Okay. So we make it thicker and thicker, something like this. Okay. So now if we look at our final results, let's looking at this final result. It looks like this. Maybe a little bit too ugly. So let's turn down this thickness. So now you see, if you take a close look, you will see there are lots of detail. Let's go to item, let's go to view. clip start, let's make it 0.001 so that we don't have this clipping. Okay, so you can see all these kind of details. If you zoom in, there will be lots of beautiful things to happen because it's just nice, and it's parametrical because you can change all this kind of value. So basically what we're doing is we try to make more details of this knitting unit, and you realize this hole becomes smaller and smaller compared to what it used to be. And it also makes the entire interlaced pattern more obvious and more sophisticated. Okay, so this is one part. Of course, you can also add this helical connection after the realized instance instead of before, but the practical experiment shows that it will be very heavy for performance to operate if you are helical connection after the realized instance, because there are so many instances to do this helical connection duplication. Here you can actually turn on and off this helical connection to actually see the difference between these two setups. Okay. Another thing that you can potentially do is to add noise, as we have done last time in the weaving clause tutorial. So let's take a set position. Okay. And let's take a noise 3D. We can plug the color into the offset, and we capture the position data of our instance, position data, and plug that into custom vector. And we also take a spline info so that make the noise different for everyone. We also take a value precision to minimize the scale so that the entire viewport does not look to be too ugly. So let's take the exponent maybe 2, 3, maybe add a 5. So you add some turbulence, then it should look kind of better because you have some noise, but it's not so ugly as you've seen earlier. If you do not have this noise at all, then it becomes, you can see kind of pattern of it. But with the noise, you add some randomness, I think it becomes better. And of course, you can add the spline parameter, as we've seen last time, but that's just another story. And you can definitely link this fourth with the animation we've done earlier as well. So if we add -1, then there's nothing. But you can see there are some weird parts because of the same reason as we've seen last time. So we're going to use the same method to clean that up by deleting geometry. So let's take a delete geometry, and it removes everything within the viewport now. And we're going to use the same fourth to clean that up. So let's take a color ramp. Basically, white is yes. White means 1, it's yes. And black means 0, which is no. So we're going to reverse it because we're cleaning up all this spline at the most beginning. And we plug this color into the selection. So now we can take a look with the result we're having. So we start from -1, and then we are animating it. It's kind of performance heavy, so we can turn off this subdivision. Okay. So initially, there's nothing within the viewport, but we are adding this setup, and they're rotating themselves. We can also control the scale of this fourth. So we take a remap 0 to 1 again, and we can add more noise at the most beginning. So maybe we add 5 at the most beginning, and then keep some smaller noise at the end of this fourth. So we start from this tiny, small but noisy unit, and they're rotating themselves, but they become more organized as this fourth is behaving. So this is kind of idea, and you can plug that into the group input, so that I don't need to go inside the node tree, but rather just control the values within modifier panel to control this entire animation. Okay, so for the moment I can turn off these helical connections. Otherwise it becomes so difficult to visualize. Okay. And we can exaggerate it, maybe 555. Okay, this is too much. 15. So we start from noisy strands, and then it becomes more organized. You can make this entire animation or this entire setup sharper with color ramp. You can use one color ramp to control 3, or you use only one color ramp to control the scale and the noise. It's completely procedural and up to you. So, but anyway, so this is kind of idea. And you can also get a different scale of this noise, maybe 3. Something like that. There are lots of things that you can potentially tweak with this setup. Okay. Next, I want to add some additional details besides just the instance in this unit. So let's go back to our initial geometry. And I want to use a preset which is called hair on surface. You do not need to worry because I'm going to explain the principle of it. But firstly, let's just deal with the setup, and actually you find that there's nothing because we need actual point guidance. So let's take a point distribute. I'm using this preset because I want to set the amount instead of density. And let's plug the initial geometry into place. So plug the points into points. So you can actually find there are about 15 curves being instanced on the original surface. So you already see how it's working. Usually it's recommended to plug this rotation into rotation. But in this case, it does not really change or give any interesting results, simply because the normal of this surface is already facing upwards. So even if you plug the rotation, it's just facing upwards. There's nothing special. Let's plug a random rotation, and immediately you can find something interesting is going on. And let's decrease the rotation a little bit and decrease the length. Let's increasing the amount. You can see there are lots of chaotic wires. And if you go back to the strand mode and decrease the length further, you can see it's chaotic wires on the surface. That's why I call it a hair on surface. And the principle is pretty easy. The principle, as you've seen earlier, it's essentially just the instancing all these kind of straight curves on the surface along with the normal rotation. But when you add some random rotation, you are making all this kind of curve tilting to some direction. And basically here, I'm using a geometry proximity for every point to wrap them onto a position close to the surface. So it's finding a surface point close to the destination or the surface you input. And of course, if you are mixing vector with every of these points, it will just be a flat lining on the surface. That's why you need a spline parameter to determine the degree of this wrapping process. So at the end, since it's value of 1, then it will be wrapped 100% to the destination. but at the start it's 0, so it will just stay at its original position. And for the middle, it's about 50%. It will stay on the middle point of the sky. That's why you are visualizing this kind of curves. Okay, but there is a downside of this method, because we are trying to do the geometry proximity for every point on these curves. So every point can find a different destination. That's why sometimes you are seeing these kind of weird or unnatural turns. And this is the limitation of this method, that there is no way to really fix yet, unless we are having kind of loop function. But it will also make the entire setup too sophisticated. So I try to not fix that, and I don't really worry, because probably no one will actually notice in a small scale. But basically that's kind of idea. So you increase all these kind of random hairs, and that's it. Another important thing is that since we're using the geometry proximity to wrap it onto original mesh, so you may want to add some subdivision, so that it does not always look for a kind of points on a quads, because it will make it looks like you will find a kind of quad pattern in this case. But people may not notice that as well, because everything is so tiny. At the end, you just connect or join these two geometries and plug that into the set curve radius. Then you have this setup being done. Let's use the strand back. And it may not be very obvious, but you can increase some length of it. And I think it's kind of interesting. But you can see sometimes the bug is very obvious, but I think it does not really matter in this case. Okay, and it works in the volume. Everything is procedural. And if you want to deal with the animation, you can try to delete points. Delete the geometry with the same color ramp. In fact, what you can do here is you can capture the noise fold, and you plug this geometry to replace it. And here you just using this captured noise, so that this noise can be potentially used in the other side of instance as well. Or you can use trim curve methods instead of using deleted geometry. There are many different ways to work with this setup. So it's up to your choice which one to choose. Okay. But eventually you will have this kind of animation. Okay. Since we're using deleted geometry, it may work the opposite. So let's just, there are many different ways, like remap 0 to 1. Let's reverse it. So we're generating wires later in the setup. As you can see, these kind of tiny wires are growing themselves somehow. Or you can just really use the trim curve. So that's it. So I hope you enjoyed this tutorial. I'll probably see you next time. Bye bye.